Today we're diving into a really cool story from the front lines of building with AI. It's this classic battle between a really complex, elegant solution and a super simple, brute force one. And it all comes down to a huge question. How do you pick the right AI for the right job instantly?
So if you're a developer right now, this is a choice you're constantly making. Does every single user query really need the power and the cost of a massive model like GPT-4? Or is something faster and cheaper, like Llama 3, totally fine? This then leads to the real engineering question. Do you build a smart, complex AI just to manage your other AIs? Or is there a much simpler, kind of dumber way that actually works better?
And this, right here, is the heart of the issue. We are living in a universe of large language models. I mean, some are absolute wizards at writing code, others are amazing at creative writing. You've got some that are incredibly fast and cheap, and others that are slower, more expensive, but unbelievably powerful. Now, this variety is fantastic, but it also creates a brand new problem. How do you automatically send a user's request to the perfect model for the task?
Well, the standard sort of high-tech answer that you'll hear everywhere is to build something called an intelligent AI router. The thinking here is pretty straightforward. You have a complex decision, so you should use AI to solve it. Makes sense, right?
So what is one of these things exactly? Well, an intelligent router is actually a machine learning model itself, usually a smaller, faster one. Its entire job is to look at a prompt that comes in and, kind of like a traffic cop, direct it to the most suitable LLM it has to choose from. It is literally an AI built to manage other AIs.
Okay, now take a look at this. This diagram gives us a peek under the hood of a really advanced router, and you can see just how complicated this gets. It's not just one model making a choice. No, this system uses separate models to first predict the quality of the response, and then another one to predict how long the response will be before the main router even makes a decision. It's a whole multi-stage assembly line.
So let's break that down. First, a classifier model reads the prompt. Then it starts running all these predictions. What kind of quality score would we get from Llama 3? What about from GPT-4? And how long would each of their answers be, which tells us the cost and the wait time. Finally, it takes all of that data and solves this complex optimization problem to pick the best model. It's a very impressive piece of engineering.
But, and this is a big but, here's the first crack in that shiny armor. Researchers measured the time it took for the router itself to think. 36 milliseconds. Now that sounds tiny, but remember this is a delay that happens before your request even gets to the main AI. It's a time tax you have to pay on every single query, just for the decision.
And that little bit of latency, that's just the start. It's all part of a much bigger problem that every engineer has felt at some point, the over-engineering tax.
This quote from Bruno Rezende Narvaez just hits the nail on the head. Are we building this incredibly complex, resource-hungry solution when a much, much simpler one would do the job just as well? Using an LLM to call another LLM feels like the textbook definition of this.
And when you put the promise of these smart routers right next to the reality, the trade-offs become painfully obvious. The promise of the perfect model for every query comes with the reality of added latency on every query. The promise of amazing quality is challenged by a really high total cost of ownership. You need to collect data, train these things, and constantly monitor them. And that automated efficiency, it means you have to constantly retrain the router every time a new model comes out.
So if the smart way is so complex and expensive, what's the alternative? Well, it turns out it's something so simple it's almost funny. A dumb switch.
The idea here is just beautifully simple. Instead of a complicated AI model, you use one of the oldest tools in any programmer's toolbox, regular expressions, or regex. It's just a system built on basic instant rules. No AI, no predictions, just good old-fashioned pattern matching.
The logic just couldn't be any simpler. The user's prompt comes in. Then, the system just scans it for a few keywords you've already defined. If it finds one, boom, it instantly routes the prompt to the right model. It's a three-step process that's over in a blink.
And this table shows you exactly how that works in the real world. You can just set up a simple list of rules. If a prompt has words like code, Python, or error, it goes straight to a model that's great at coding, like DeepSeek. If it has summary or email, it goes to a fast, cheap model like Llama 3 8B. And if nothing matches, it just goes to a solid, all-around default model.
So what's the latency penalty for a system like this? Here's the killer detail. It's effectively zero. A regex scan takes microseconds. Compared to the 36 milliseconds of the smart router, well, this is basically instantaneous.
You have completely eliminated that routing tax. Now, I know what you might be thinking. Okay, that's way too simple. There's no way it's accurate. But the surprising thing is, in production, this dumb approach is incredibly effective. This simple little hack can correctly route 90 to 95% of all queries. It just turns out that most of the things people ask for fall into a few predictable buckets that keywords can easily catch.
All right, so let's put these two philosophies head to head. When should you go for that sophisticated AI classifier, and when is the simple, dumb switch the right call?
This comparison really makes the trade-off crystal clear. The smart router adds a noticeable delay. It takes a ton of work to set up and maintain. And for all that trouble, it might give you a slightly higher peak accuracy, maybe 98%. The dumb switch, on the other hand, has zero added latency, is trivial to set up and change, and delivers an accuracy that for almost every application is perfectly good enough. You're basically trading a few percentage points of accuracy for massive wins in speed, simplicity, and cost.
And that brings us to the final question that I think every engineer, every product manager really needs to ask. When it comes to user experience, what actually matters more? Is a good enough decision that happens instantly a better experience than a slightly more perfect one that forces the user to wait? For a whole lot of people, the answer is to choose speed and simplicity every single time.